section to go, and then we are going to be ready for a test. So it's important that we get these kinks worked out. It is also important that we spend quality time on our homework. We get good by practicing, and some of you just aren't putting enough time into it, I don't think. Also, just as a kind of point going forward for you in your life, in your college life, review days don't happen in real life. So as we're learning material, as I'm giving you information, you need to spend some time with that. Go back over your notes. And some of you just didn't. I mean, some of these scores were crazy. All right, so who found one? You guys had the one heart quiz. All right, who has a question about something? You missed something, and you haven't been able to sort it out yet. Number one. Number one is a big determinant, a 4x4 determinant. So we talked, when we did this, we just picked the top row and we expanded on that. But then we decided that it is smarter to choose the row that has the most zeros in it, because that will greatly cut down on our work. And especially on a test when you have, I crossed that number out, was that a -7? But when you don't have unlimited time, let's do this the most efficient way we can, which would be using the bottom row, because that's the row that has the most zeros in it. So the only number in the bottom row that counts is the -7. Now, that position, watch, that position, I have to figure out whether I'm going to leave that sign the same or I'm going to change it. This is where I start my alternating sign changes. So same, change, same, change, same, change. That sign's going to change. If you get to here, you can get to here any way you want. I come down and across. That makes no sense to me. Same change, same change, same change. It doesn't matter. Same change, same change, same change, same change, same change, same change, same change. It doesn't matter how you get to this position in this matrix or this determinant, that position's going to change. Now, what you can't do is same change, same change, same change. No, no, no. There's no skipping. You have to go continuously. Any way you want to get to here, but get to there without skipping. All right, so that sign's going to change. Now, I'm going to cross out that row because I'm done with it. I have nothing more to do. That's the only number I need, so I'm just going to go ahead and physically cross out that column. Now, if I need other columns, if I'm using other matrices or determinants, then I usually just cover them up as needed. But since that is the only one I'm doing, I might as well just cross it out. David?
Oh, you said it to me.
Huh?
You said it to me.
So when I take out the column and the row that contain the 7, when I take those out, then I am going to copy down all the numbers that are left in that determinant, and now evaluate that determinant. When I evaluate that determinant, I recopy the first 2 columns, and then start multiplying. So assuming that I'm multiplying right, I got 2. Now what do I do with those 2 numbers? Subtract them. So 2 minus 8 is -6. And then what do I do with the -6? Multiply it by 7, so the answer is -42. The determinant has a value of -42. All right, easy process, but you gotta know. Everybody good on that now? Okay, David?
If we just did it like the regular way, or we didn't like make take off the,
Okay, this is the only way. This is the only way to
can't
do
you just
this.
like extend it
No.
anyway?
No, that works with the 3x3 only. And if that's gonna confuse you, then do your 3x3s by extension. So like this 3x3, I could have taken the bottom row, written it out, crossed off rows and columns, and had little 2x2s to do. To me, that's more work, but if this is how a 4x4 has to be done. 3x3s can be done this way too. All right, who else has a question? Aiden?
E.
E. It says multiply C times B. Well, before I write it all out, what are the dimensions of C? C is a 3x3. And B is a 2x3. Uh-oh, that is not possible. Because in order to multiply, these two dimensions have to match.
And you're not allowed to change.
No, that would be a different problem. That would be a different problem. Which one? J says find the inverse. I want you guys to shut up. J says find the inverse of A. So matrix A looks like this. So the inverse is a two-step process. First, I need the determinant. So the determinant is 3 minus negative 8 or 11. Then I take these two guys, this is this random part, switch them. These two guys change their signs. Oops, change their signs. And then I divide all these numbers by 11, by the determinant. Simplify if you can, you can't, so that's the inverse right there. David?
I got the answer and you took off a point.
I'll have to look at it and see. All right, who else has a question? Alana? H? H says find the trace of C. Here's matrix C. And the trace, what does a trace mean, guys? How do we calculate a trace? It's the sum of these numbers right here. It's the sum of those, so the answer would be 7. Just add them up. In order to find a trace, just like with an inverse or a determinant, the matrix has to be square. If it's not square, you can't do any of those 3 things. Okay? All right, let's put those away. I want to do some of today's notes. By the way, all those things are the good things to know for the test. Those are the things that are easy. So make sure you know the easy stuff as we get ready to tackle some of this harder stuff. Okay. So now we're going to do what's called some linear programming. So let's turn to our notes, 7-5. And we're going to do problem number 1. So let's read it. You read it while I get things set up here. Linear programming problems are actually very, very realistic. People have to do these things. People have to figure these things out. All right, so let's see what's going on. First of all, can you take every number out of the problem and stick it in this chart, can you figure out where to put all the numbers? Because that's really what the chart's used for, is just kind of organize everything. So there's a lot going on. They need at least 180 units of N. Where is the 180 going? Total for N. And 90 units of P, so I'll put a 90 here. Does that make sense to everybody? Their supplier has 2 brands of fertilizer for them to buy. Brand A costs $10 a bag. Where does the 10 go? A cost. See, it's kind of a matrix. And brand A costs $10 a bag and has 4 units of N and 1 unit of P. That's brand A. And brand B costs $5 a bag and has 1 unit of each nutrient. Johnson's Produce can pay at most $800 for the fertilizer. Where does the $800 go? Well, I hope it goes right here, since that's the only box left. Would that be the total cost? Yep, that makes sense. How many bags of each brand should be purchased to minimize cost? So maybe I'll let the number of A bags be X and Y can be the number of B bags. Now, I am fine if you want to use A and B as your variables, that would be fine. I'm graphing this, I'm used to this being X and this being Y, but you can do A and B if you'd rather. All right, you with me? All right. Now, every time we do a linear programming problem, they're called optimization problems, because we're either going to be looking for the high point or the low point, the maximum or the minimum. If we were doing profit, if we wanted to profit, we would be maximizing, right? But in this case, we're doing cost, and we want to minimize cost, right? So on max min, I'm going to say cost. And how will I calculate the cost? What is my cost equation going to be, or my cost expression? 10x plus 5y. How much is it going to cost me to buy this fertilizer? Well, it's going to cost me $10 for every x and $5 for every y. So this is what I want to be as little as possible. Now, the constraints are the framework that this problem has to exist within. So let's look at this top row right here, the nitrogen row. 4 x's plus 1 y has to be what? Not equal to 180. Read the problem. More than, greater than, or equal to 180. Don't we need at least 180 units? What does at least mean? That amount or more, right? All right, what is this constraint right here? What does this one say? X plus y is greater than or equal to 90? And then what about this bottom row? What does it say? 10x plus 5y
Is
less than or equal to 800. That one's a less than. You've got to read the vocabulary in the problem. Now, you know what's going to happen. I'm going to graph all these things. I'm going to have shading all over the place, because inequalities get shaded, and somewhere there's going to be overlap. Hopefully. That's the goal. Right? Now, there are 2 more constraints that are implied always in these problems. You do not have to write them down. I've taken it into account when I built the grid. But would you agree that x and y have to both be positive? And that's always the case, because these are always real-life problems where you're building widgets or you're buying fertilizer, so negatives don't come into play. That's why the graph is only quadrant 1. Okay, now, I know you know how to graph, but we're gonna make your life and my life easy. Remember, I have to grade this. So I want this to be as easy as possible. So first of all, these are pretty big numbers. So I don't think I'm gonna count by ones because I don't really wanna go 180 and 800 and all that. So let's count by tens. So our grid will be tens. You can set the scale however you want. I wanna use tens. Please don't use ones, but use whatever you want. When you do this, I'm gonna do this one in blue. Feel free to use colored pencils or pens, by the way. I'm gonna do this top equation in blue. So the first thing I'm gonna do is I'm gonna cover up the 4x. So I'm gonna let x be 0. And if I do, then my y-intercept is going to be 180, which is 18 on my thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is. Now when I label it, I'm still labeling what it actually is, 180, but I only counted up 18 because I'm using a scale of 10. Now, let y be 0. What is your x-intercept? 45? Is that right, 45? And then we're gonna go ahead and with this, it'd be great if you would use a straight edge. I don't really have one long enough, so I'm just gonna try to connect these, but we want a nice straight line. And where is that shaded? Your choices are in a triangle or out.
Under.
It's greater than mean. Greater than does not mean underneath.
Definitely over. It's definitely over now.
It's out here. That's right.
The whole time.
All this is shaded out here, greater than. I'm not gonna shake his, makes my board even worse, but we're shaded out here, right? All this. All right, now I'm gonna choose a different color. I'm gonna do purple. I'm gonna do this guy. And I'm gonna graph it exactly the same way. So my y-intercept is 90. And so is my x-intercept. So I'm gonna connect those with a nice straight line. And where is that one shaded? Also above. So now I'm looking at this area right here. Well, all that, but bounded like right here. Would everybody agree? And then I have one more. So I'll get my handy dandy red marker. You'll have a calculator to help you with these problems, but if I cover up y, it looks like x is 80. Oh, x is 80. And if I cover up x, it looks like y is 160. I'm going to connect those with this nice straight line. And where is that one shaded? Under. Okay, so here you go. You're shaded above blue, above purple, and under red. Do you see a little triangle right there? When you do an optimization problem, you get what are called vertices. So you have this overlap shaded region, and these points are called the vertices of that, in this case, triangle. Your answer is going to come from one of those vertices. So we need to figure out what they are, and then we're going to plug them in here and see which one is the lowest value. All right, so this point, I'm just gonna start with this one. This one is the intersection of blue and red. So blue is 4x plus y equals 180, and red is 10x plus 5y equals 800. You can maybe tell what that point of intersection is from your picture, but I don't want you to rely on that because the intersection is not always whole numbers. And it's really hard to tell a 1/3 from a 1/4 on a grid this size, right? So how do we algebraically determine the point of intersection of the blue and the red lines? You could eliminate, substitute, Kramer's rule, inverse method, whatever flips your switch. Substitution, did I not say that? You can definitely substitute, but you know I won't because I'm always going to eliminate. All right, I did a bunch of math in my head. I think x is 10. And if x is 10, then y has to be 140. Correct me, please, if I made a mistake. Now guess what we get to do? Have some more fun. Now, I don't care which one we do next. This one is blue and purple. So blue and purple. This one's a little easier. I got 30 and 60 for this one. And then finally, purple and red. I got 70 and 20, so I'm gonna have you check me on that. This is like an emergency. Hurry up. All right, anybody else get 70 and 20 for that one? All right, so let's make sure everybody's on the same page here. We did a lot of arithmetic. Once you get all of your constraints, all of the inequalities that came out of your chart, once you get all those graphed, you should be able to identify a region that is shaded by everything, total overlap. The corners of that shaded region must be figured out. You gotta figure out what they are. So we did 3 sets, I did 3 sets of elimination, you could have done something else, to find where these lines are crossing. So you'll notice on the paper, I wrote vertices. So your vertices are these points right here. So 10, 140, 30, 60, order doesn't matter, and 70, 20. So those are my vertices of my feasible region, my overlap area. Now I'm going to take each one of those, that's an X and a Y, and I'm going to plug it in right here. If I have 10 X's and 140 Y's, how much is it going to cost me? Well, 10 times 10 plus 140 times 5, you get $800. 30 times 10 plus 60 times 5, $600. 70 times 10 plus 20 times 5, $800. So if you're this guy or this Johnson's Produce, what are you gonna do?
that outermost line, or most likely the vertices at 10 to 40 or so.
You're gonna buy 30 bags of A and 60 bags of B, and it's gonna cost you $600. So number of A bags, 30. Number of B bags, 60. Total cost, $600. Alright, while I'm setting up the next one, read it, see if you can fill in the chart, write your constraints, see how far you can get with it. While I get ready. I'm gonna let X be the number of A days and Y be the number of B days. Does that make sense? Does that seem reasonable? That's the question. How many days should each group operate? Think, what are you doing?
Sorry.
No, I know what you're doing. We don't do that. Put it in your backpack. All right, were you able to fill in any numbers here? All right, let's see. I think it's pretty easy. What do I do with the 24, the 6, and the 30? The very first numbers, where do they go? 24, 6, and 30, aren't those the totals? And then factory A is 8, 1, and 2, and a cost of 2,000. Factory B is 2, 1, and 8, and cost 4,000. Are all the numbers in the problem now? They are? What number's not in the problem?
Last one?
Well, I have put every number I have into my box, right? I have an empty box, okay, fine, I have an empty box. The chart is used for one thing, and that is to take all the data from the problem and organize it. If there's something missing somewhere, that's okay. I bet we have to figure out what that number is. So I'm not gonna be alarmed that I have an empty box. I'm minimizing cost again, right? And what's my how am I gonna calculate my cost? 2,000 X plus 4,000 Y. $2,000 for every X day and $4,000 for every Y day. Okay, let's look at our constraints. Can you write some equations from here? What do you think? What do you think? 8x plus 2y is greater than or equal to 24? plus y is greater than or equal to 6, and 2x plus 8y is greater than or equal to 30. Did I get all the numbers right? So coincidental here. Is that right? Okay. And then also imply that you don't have to write it down is the numbers have to be positive. Last time we had great big numbers and we used a scale of 10. I think this time we can get by with just a regular scale, don't you? Or even making it a smaller scale if you wanted. But I think I'm just gonna go ahead and use ones. So, I'll call this one red. On my red equation, my y-intercept will be 12. And my x-intercept will be 3. And we are shaded out, out, out here. All right. Now we'll do a purple equation. What are my intercepts for my purple equation? 6 and 6. Where's that one shaded? Out. All right. And then let's see, it looks like my x-intercept for my blue equation, my x-intercept is 15. And my y-intercept is, what's 30 divided by 8?
3.75.
Yep, 3.75. My lines are supposed to be straight, and I usually think they could be. That's supposed to be a nice straight line. Where's that one shaded? That was shaded above 2. Now, I've actually had this problem done somewhere before. I mean, I know I graded this problem at some point, don't remember. But we get kind of programmed to look for a shaded, like, little space. Is this triangle right here the overlap area? No, it is not. Where's the overlap area? Isn't it all of this? It's all of that. So what are the points in the first quadrant that bound that region? Isn't this one of them? And here's one. And here's one. And here's one. So we don't have a polygon this time. We don't have like an enclosed figure. But we do have 4 vertices. And 2 of them are gimmies. Oh, wait, no, not 6, 0, 15, 0. 2 of them are gimmies. This one and this one are automatic. These 2 we're going to have to find. So just like we did before, so go ahead, find where these 2 cross and where these 2 cross. 2433. Let me know if I'm right, or if I need to fix something. I'm good. All right, so let's make sure we're clear on the steps here, because you're gonna do the next one by yourself. All right, so here we go. First thing we did was fill in all the numbers in the chart, and then let the chart help us come up with our constraints. We graphed them. After I graph these, I have an area that is shaded blue, purple, and red. The corners of that shaded region are right here. Some of them were automatic right from the graph. Some of them I had to do some elimination and whatever to find. Last step is to do what then?
Figure out which one's the best.
Figure out the cost at each of those points. So at 0, 12, that would be 4,000 times 12, which is 48,000. And then 15, oh, I think I know that one, would be 30,000. How did I do? Are those the values that you got? So now all that work, now we have to answer the question. Okay? So what's the question or answer? What's the answer going to be? What are you going to tell this person to do? He's gonna operate 3 A days and 3 B days, and it's gonna cost him $18,000. Got it? Did you guys do these last year? They look familiar? You don't remember? Okay, too busy talking about basketball. All right, let's try number 3. Number 3, here we go. I'm not gonna say a word. You can help each other if you need help. But I'm gonna sit up here and do it on my own. And then when I'm done, I'll put out what I got on the board and we'll compare it to what you got and we'll see where we're at. Take hers and get this done before you have to leave. Before you get too far, how does my chart compare to yours? How do my constraints compare to yours?
Constraints look good.
Oh, it looks good? All right, we'll continue on, let's graph them, let's see what you come up with. Did your picture look a lot like our last one? I think these are all shaded out again. So I got this same thing that happened last time. Is that what happened for you?
It can't be. I think that's the left one.
No, I got,
No, I think I just messed up. I didn't
I'll tell you why. I'll tell you to keep still. I'll tell you to keep still. We're like 3 times. I'll tell you or we could just call you. Yeah, I know. It's so the page.
The negative x I'm doing this and this. I don't know.
I did the same thing. What am I doing wrong? Did anybody get 80-20 as one of your points?
I got 120.
Alright. I'm looking for the intersection of purple and red.
It's x plus 4y.
2x plus 4y equals 320. Negative 2x minus 8y equals negative 400.
Why are you doing that minus 4y?
Yeah, can you just leave it as x minus 4y?
You can just
I
make the box
could, but
negative.
that shouldn't change my answer. Let me do that and see. Because it should, I mean, yeah, it shouldn't change my answer. 2x plus 4y equals 320. And that was x minus 4y equals
I think we're going
x equals.
Is it just practice or is it price?
to. Very funny.
Do you have a math?
That can't be right.
That's what I want.
That's what I got.
The pen.
Why can't x, oh, I guess, well. Oh, yeah, okay, I'm plugging it back in the wrong equation, that's my problem, okay. So if x is 120, then, yeah. Then, y is 20. Yeah, that was my problem, I kept getting 20 for my y, but then I was plugging it in this equation for some reason to get it this way. Okay, now that's it. All right, how do those points look?
Good.
All right, so then we gotta find the cost of each one of those points. So let's see. This one is gonna be 6,000. This one is also gonna be 6,000.
Isn't it 60,000?
Oh, 60,000?
Am I gonna get it?
Yeah, yeah, go golf.
Hurry up.
No, Rob.
Hey, good luck, man. Had a good score, dude.
74.
I got 48,000 for this one. And I also got 48,000 for this one.
You just wrote it.
No, this isn't an uh-oh.
That's a good thing.
What does this do for that? Whoever this person is, he has options. That's right. He has options. He can either do 40 hours of number one and 60 hours or 60 operations of number two and pay 48,000, or you can do 120 and 20 and pay the same amount, right? So depending on whatever things are going on in these factories, you can make the determination which one is best. Okay? All right, we got, I'm not gonna do the other two right now, we might do, there's only one more. We may do that one next time. What I wanna do right now, though, is a couple of things. First of all, I wanna show you something really totally cool that Mr. Shadio showed me. This is cool. I cannot remember, there's a name for it, some guy figured it out, but I can't remember his name.
Shady shape.
No, it's Mr. Shadio showed me, but I don't think Mr. Shadio did all of it. I want to show you, something. The very first partial fraction problem that we did was this one. And I'm using this as an example because this was the easiest one we did. Okay? And you know that to do this problem, you are going to factor the denominator, and then one fraction is over x minus 5 and the other one's over x minus 3, right? This was a problem 7.4, number 1. So if you still have that available, I want you to compare the answers we get. Okay. Now, what would make this problem undefined? There's two values, right? One of the values that would make it undefined is 5, and one of the values that would make it undefined is negative 3. Well, how did we do this? I'm gonna have to get back to it because now I can't remember how we did it. It was really slick, whatever we did. Oh. I don't know, I have to get back with you. Sorry about that, I forgot. Other thing I want you to be able to do this problem though. You're not gonna be able to do the shortcut because I forgot it already. But you need to know how to do this problem, one way or the other, okay? You also need to know how to find the area of a triangle. And I don't care how you do it, but if you're smart, I think you'll probably do it the determinant way because it's way faster and easier. Alright, so let's review that real quick. How do we find the area of this triangle? What do we have to do first? Really, no matter how you're doing it, you're going to want to build two vectors. And I just always do this one in this way. So x, y, x, z. It really doesn't matter if you're doing it with the determinant. If you're doing it with the dot product, it does matter. But if you're doing it with the determinant, it really doesn't matter which vector you use. Alright, so what's x, y?
2 negative 7.
2 negative 7. And what's x, z? 4, 3. So we're going to build the determinant from those numbers. Just write them right like I got them, except no commas and stuff. So what's the value of that determinant? I think it's 34.
Yep.
And then what do I have to remember to do? Divide by 2. And the area of a triangle would be 17.
But it's not.
If we had a parallelogram, we could do exactly the same thing, except we wouldn't divide by 2. The whole thing would be 2 of those 17, so it would just be 34. Okay, the other thing you need to be able to do is solve a little 3 by 3 using Gaussian elimination. So if I had a system of equations that look like this, okay, there's my system of equations. X plus 2y plus 3z equals 4, and so on. You need to remember how to get zeros here first. So I would, you do it your own way, I would multiply the top row by negative 2, right? And then add it to the second row. So that puts a 0, a negative 3, a negative 2, and a negative 3. And then go back to the top row, multiply it by -3, and add it to the bottom row, so I get 0, -5, -9, -10. Now, this problem hasn't been rigged at all. I randomly rigged it up. So we have one more 0 here, right here.
Tomorrow is a special school math, and we're asking you to wear special colors. So with your school band,